So today we're going to be talking about factoring using GCF for polynomials. So the first thing we're going to do is just talk about what is factoring, what is our definition of factoring. Here is the definition of factoring. Factoring is when we separate an expression into numbers or variables that can be multiplied to produce the original expression. So we will take a look in a second on what this looks like. One way that we can factor is using GCF. You might have seen GCF previously in another class. Remember, this stands for greatest common factor. And this is one of the ways that we will factor our polynomials. So greatest common factor you've probably seen before has to do with numbers. So it can be numbers. However, we're also going to be factoring variables today as well. So it can be numbers and or variables when we talk about GCF. So let's take a look at an example to see how we would use this to factor. So I have an example here. We want to factor 27y plus 18y. And the first thing that we are going to do for step one is to list our factors. So I have 27 as one of my coefficients. So I'm going to list out all of my factors for 27, starting with 1. So 1 times 27. And then move on to 2. Can I multiply 2 times something to get 27? Not in this case. So we'll go to 3. Can I multiply 3 times something? Yes, I can multiply 3 times 9. And then keep going. Are there any other numbers that I could multiply? No. So this would be all my factors for 27. Now let's list out the factors for 18, starting with 1. So I can do 1 times 18. I could do 2 times 9. I could do 3 times 6. Can I do any others? No. So I would stop here. I've listed out all my factors. After you list them out, you can identify the GCF. Right? So the greatest common factor. So I see some common factors, right? 1, they share in common. They also both have 3 as a factor, but the greatest one is going to be 9. Both of these have 9. So the GCF is going to be 9. After I have listed our factors, the other thing we have to look at is the variable. So step 2 is going to be looking at the variables. You want to see if they have any variables in common. So looking at this expression, this has y squared, and this one also has a y. So they both share this variable in common, y. So both the GCF 9 and the GCF, the variable y, are going to be in our factors. So write out your GCF on the outside, so 9y. And then we want to divide. So when I divide it, I'm going to write out the original expression on top. So 2y squared, or sorry, 27y squared plus 18y divided by our GCF of 9y. Okay, so the original expression divided by our GCF, which we identified in step 1 and 2. So now all you have to do is solve it and divide. So starting here with the number, I'll start with the first term, 27y squared. 27 divided by 9 is going to be 3. Y squared divided by y. A trick that you can do when dividing is subtracting the exponents. So 2 minus 1 is going to be 1. So we have y to the first power. Dividing the second term, 18 divided by 9 is 2. and these y's will cancel out, right? Because 1 y to the first minus y to the first is just 0. So these will cancel out. So I'm just left with 3y plus 2, and don't forget your GCF on the outside. So we divided it, and this is our answer. This is factored. So we have our GCF on the outside, we have a new expression that's being multiplied it. This is our factored solution to this original expression. Let's try another practice problem. I want you to try this on your own. If you need to, rewatch the first example so that you can have all the steps written out and you know how we divide it. And once you're ready, I want you to pause this and try to solve this expression on your own. And then come back for the answer. Okay, hopefully you paused. We're going to solve this now. So step 1, remember, is to list your factors. So my first number is 7. So factors of 7 is just 1 times 7. And then list my factors for 21. For 21, I have 1 times 21, and I also have 3 times 7. I see that the GCF is 7. So my GCF is 7. And then I also want to see if there are any variables that they have in common. When I look at my original expression, 7u squared plus 21u, I have u in common. So I have this variable in common. This is another GCF. And then I'm going to write this out for step 3, and I'm going to solve. So step 3, I want to write out my GCF on the outside. I take the original expression up top, divide it by the GCF, and then I just want to simplify this. So divide this first, 7u squared divided by 7. Well, 7 divided by 7 is just 1. So you can write a 1 here if you want. And then u squared divided by u, remember, subtract the exponents. So 2 minus 1 is just 1u. And then 21 divided by 7 is 3. U divided by u cancels out. So we're just left with 7u times u plus 3. You could have also written it like this, without the 1 in front. This would be our factored answer. So this is now factored. This was our original expression that we were factoring. Let's take a look at a second example. Here we want to factor negative 4a squared b squared minus 8ab to the third power plus 2ab squared. So we have multiple variables in this case, but it doesn't change too much on how we factor. So we're going to follow the same steps, and we're going to factor this the same way. So our first step, remember step 1, is to list our factors. So let's start with the first one, negative 4. So when we have negative numbers, you can just list the factors twice because there are multiple combinations. So let's just start with positive 1 times negative 4, positive 2 times negative 2, and then we have another combination which is negative 1 times positive 4. I'm not going to list negative 2 times positive 2 because that's the same as this one right here that we already wrote. So these are all the possible factors. Make sure that you account for the fact that you could have these negative signs switched. Okay, now we have negative 8. So I'm going to list out the factors for negative 8. I have 1 times negative 8, 2 times negative 4, and again, my other factors, negative 1 times positive 8 and negative 2 times positive 4. Our last one is 2. So I'm going to list out the factors for positive 2. There's only one possible one, which is 1 times 2. So again, looking for the greatest common factor, I can see that all of these have a common factor of positive 2. So my GCF is going to be 2. Now I'm going to look at my variables. So variables that they have in common. So let's start with A. So I look here at the first one, I see I have A squared. I also have a single A right here and a single A right here. Next, let's look at B. So I have two B's right here, B squared. I have B to the third power, and I have B squared. Now, when you have these exponents right here, and you can see that instead of just one B, we can actually have two in common. Right, because the greatest common factor would be B squared. So we can actually factor out one A and two of these B's. So when we write out our factors, it would be 2 from the GCF times A times B to the second power. We always want to take out as many common variables as we can. So now I'm going to write the original problem again inside my parentheses. And then divide it by my factors. So divide this by 2ab to the second power. And then remember, when I divide it, first thing I do is just go 1 by 1. So this first term, negative 4 divided by 2, is going to be negative 2. A to the second power minus A to the first power leaves me with A to the first power. B to the second minus B to the second, that's 0. So those will just cancel out. So I'm just left with negative 2A. Moving on to the second one, negative 8 divided by 2 is negative 4. A to the first divided by A to the first cancels out. B to the third minus B to the second, I'm left with B to the first power. And then my next term, 2 divided by 2 is just 1. A divided by A is also 1. And B to the second divided by B to the second is 1. So all I'm left here, this whole thing actually cancels out. And this we would just write as 1. Because 2 divided by 2 is 1, A divided by A is 1, B squared divided by B squared is 1. So I would just write this as plus 1. Now, writing the factor on the outside, this would be my entire thing factored. I pulled out all of the common factors. The GCF was 2. The variables, I could pull out an A and also 2 of these B variables. And this would be my answer. This would be the factored form of this polynomial right here. Okay, so let's try one more practice. I want you to do the next one on your own and try to solve it entirely. Here is our practice problem. Try to pause and factor this on your own first and then come back and watch the answer. Okay, so if you want to see the answer here, first thing we have to do, step 1, is to list our factors. So I'm going to list the factors for 10. We have 1 times 10 and 2 times 5. List my factors for 9. I have 1 times 9 and 3 times 3. And then for this one, remember there's always an invisible 1 in front. So this would be factors of 1, which is just 1 times 1. So our GCF in this case is positive 1. Alright, now let's look at the variables. So step 2 is the variables. So let's look at G. I have G to the second, G to the first, and G to the second. So the greatest common is G to the first power. Now let's look at H. I have H to the second, H to the second, and H to the second power. So the greatest common factor is H to the second power. So when I write out my factor, so step 3, I'm going to factor it now. So my GCF is just 1. My variables, I have g to the first power and h to the second power. And then I just need to write out my original and divide. So I'm going to write out the problem here inside my parentheses. And we don't actually need to write this 1 in front. I'm just going to get rid of this because we don't normally write the 1 in front. It's always implied. So I'm going to divide it by gh squared. So gh squared. Okay, now we divide 1 by 1. So 10 divided by 1 is just 10. So the numbers are going to stay the same. Okay, second power minus g to the first power, so g to the first power. H squared divided by h squared is going to cancel out, so we aren't going to include that one. 9 divided by 1 is 9. G to the first divided by g to the first is going to cancel out. H to the second divided by h to the second is also going to cancel out, so we're just left with 9 so far. And then this last one, g to the second divided by g to the first, so g to the first power, and h to the second will cancel out as well. So this is what we're left with. gh to the second power on the outside, then 10g plus 9 minus g. This would be our factored answer, and this would be the original polynomial. So this is the polynomial factored. Okay, so I know this was a lot. I recommend you pause and re-watch the video. That way it can help you better practice. And if you have questions, make sure to bring them to class.